Good. Well, thank you all for coming. When I told my parents I was giving a talk today, they of course are happy and proud for me. They laughed, saying, "Who wanted to listen to me talk about machine learning for half an hour?" And people showed up, so I don't care. So I'm happy. So this is my first ever talk I'm giving. So please be nice. No, don't heckle me. Don't shout at me. So yeah. So a bit about me. My name is Anthony. I'm a recent graduate of the University of Gloucestershire with a degree in cyber and computer security. After my graduation, I started as a tier 1 SOC analyst, where I stopped hackers from attacking our systems, but in case our client systems. We worked in banking sector, healthcare, manufacturing. And after that, I pivoted into a shift lead/senior role. So now I'm in charge of a team of about 5 lads on a shift. And whenever they have any issues, they come talk to me and I try and fix it. If not, I'll give it to somebody else and they fix it for me. So back onto this talk. At university, I needed to complete dissertation. So my friends were doing dissertations on healthcare and cybersecurity, in education cybersecurity. I thought it'd be a good area to do machine learning because it was an interesting, so machine learning is quite an interesting topic for me. And phishing, because phishing is such a big issue in cybersecurity. However, I had no experience in machine learning. So I was reading the Dummy's Guide to Machine Learning in my lectures, which my lecturer thought was quite funny. When I was telling about it, he said, "Anthony, you sure it's a good idea?" And it worked out, so I can't complain. Well, quick catch-up. What is phishing? Phishing attacks are not a new cyber attack vector. The earliest known phishing attack was in the 1990s, a good 12 years before I was born. So just to age you here. And it was first used on AOL online. Attackers would pose as AOL employees and trick victims into handing over their login credentials, which they would then log into the account, steal credit card information. However, with the increase of advanced instant communication, such as email and text message and DMs on Instagram or Facebook, phishing has changed for more personalized attack, which I'm trying to stop with this machine learning. Why is phishing such a big deal? On average, 3.4 billion phishing emails are sent every day. This is a conservative estimate, so it could be 4 billion, 5 billion. Phishing campaigns are incredibly easy to create. At work, we can make a good, convincing phishing campaign in about 20 minutes, 30 minutes. And we send out to our clients to test their phishing responses. And probably about half of the users will click on a link and we pop up a message saying you've been successfully phished. And this is a good way. And as I say, 3.4 billion phishing emails sent a day. If 1% gets through, that's about 34 million emails being successfully phished. Again, lists of emails can be easily found online. So hackers just crawl through data sets, find emails, and send it out. So what are the current methods used for phishing detection? There's about 4 main types. There's machine learning based, which we're covering up today. There's content based, which are looking at heuristics and word-based, so looking at keywords within phishing emails. And there's list-based, more traditional blacklist, real-time blacklist, whitelists, as well as DNS lookups, so looking at where the DNS comes from, where phishing names come from. But yeah, as I said earlier, this is looking at the machine learning-based. So traditional methods, IP blacklisting. IP blacklisting is a process of collecting IP addresses in a list and prohibiting any email communication attempts to come from that IP. This is a very old method used for 20 years. It's still effective to a degree because to realize an IP address is bad, someone has to be hacked first to detect it. So someone has to actually get phished to first understand it's a bad IP address. On average, it takes about 12 hours for a phishing IP to be identified. As I said, this leads to users and organizations to be vulnerable to cyber attacks. NLPs. NLPs are natural learning processes. This is a popular way to detect phishing emails. This is when you actually look at keywords within the phishing text itself. So, for example, we're looking at action verbs to influence the user clicking. So, important, click here, click now. This is a really good method. However, its false positives are quite high. For example, when a bank emails you saying to change your password, people might think it's phishing. It gets sent into that spam box and might get sent to a user when it's important to change your password if a bank says so. OCR. OCR, optical character recognition, is typically a business solution used for scanning documents for files onto the online system. However, it can be used for machine learn can be used for phishing to actually read the words out and put it in a list. However, it's not the best. It's not the best method of detecting it due to the fact there's a lot of false positives. So in my dissertation, I thought, well, it's always old methods. What are the current, up-to-date new methods? So I was looking at 3 machine learning algorithms to try and detect these phishing emails. I used the Bayes algorithm, decision tree algorithm, and the random forest algorithm. So this is when it gets a bit more technical, so please bear with me. This is the bit more technical part. Bayes classification is a machine learning algorithm based off Bayes probability. Bayes works off assumption. For example, base level is an apple is considered fruit because it fits certain criteria. It's being red or green or being an oval shape. And this can be passed on to machine learning. So if you have a machine learning data set of phishing emails, it knows it's phishing due to its internal data, due to its heuristics inside it. Bayes is a simple machine learning algorithm, easy to implement compared to others. The amount of training time needed is quite small. And with machine learning, training is so important. If your model takes 5 days to train compared to 2 days to train, that's 5 days extra, which is critical. Decision tree algorithm is a tree-based technique which uses any path. Sorry, the decision tree algorithm is a tree-based technique which any path begins a root. So as you can see at the top, with a root node, which splits down to a decision node, which goes down to terminal node, it all splits down to a decision tree node. This is, and once it goes down to terminal node, it doesn't split anymore, and the decision tree splits down. So the data goes down like a tree. Random forest, also known as FS, random forest shares many likenesses to decision tree classification. However, random forest is made up of many individual decision trees. So it gives more variability and it gives more data to run through. Each decision tree has that prediction, and most common prediction becomes a random forest prediction. So the strengths and weaknesses of each of these algorithms. Bayes performs well with small data sets and is quite fast. However, it relies on the assumption of important and independent features based off biased probabilities. So if you have quite a biased data set, that can really throw off the machine learning algorithm. With accuracy about 95% accuracy. Decision tree uses less data preparation during pre-processing. However, this algorithm can scale, so it's easy to scale to add more data in. It takes a long time to train this model. That's a weakness of it. With an accuracy about 85%. Random forest uses less data preparation during pre-processing. However, it uses a lot of computing power to actually run this algorithm, with an accuracy of about 94%. So even time for more technical stuff now. For programming, I use the Python programming language. Don't judge me, because it was the easiest language I knew. I chose it because it had a large amount of resources online, and GitHub was always there, so it was always a good thing to have. Machine learning-based libraries were valuable, pre-made, which was good for me. Mainly is because I have the most experience with it, so I chose the one I was most comfortable with. So, machine learning is based off data models and data sets. Data sets are really important to have. It's really hard to spec because a lot of researchers like to hide their data sets and they don't like to share it out. So I unfortunately have to use a quite old data set from about 10 years ago. So for the phishing emails, I use the NASRO phishing corpus. There was about 4,500 phishing emails in there. And to detect for real emails to compare it against, I use the Enron datasets used for the Enron financial leak back in the early 2000s. However, before the machine learning was taking place, I had to first clean the data. Datasets were chosen were not suitable for machine learning. This is because the NASRO dataset was actually in an mbox file. Mbox files are a archived email file, so it's all it's not ready yet to be put in my model. And also, all the emails had to have all the emails came through as HTML, so I had to strip out that HTML afterwards. I also had to normalize and tokenize the datasets because having apostrophes, having commas, and that stuff could mess up my data, so I had to tokenize it and make everything standard. So I could do that manually, but I wrote a small Python script to go through the whole data sets to I went through the whole data set to clean it using Python, if this video will work. So as you can tell, we have the raw HTML of the email here, and this is the outcome. So it stripped out all the HTML and made it all nice and pretty, ready for my algorithm to work better. This took about 20 minutes to run from 5,000 emails. So my laptop was screaming at the time. The fans was going mental. However, some of the phishing emails had to be removed because they contained zip files, they contained very weird formatting errors, so I had to take those out. So to classify which emails were phishing, which ones were non-phishing, I used the classification method ham and spam. Ham and spam classification method is a standard process for detecting phishing and non-phishing emails, with ham being non-phishing and spam being phishing. And in my model, I put ham as 0 and spam as 1. So to actually measure the success of my algorithm, I based off 4 metrics. Time metric, accuracy, recall, and precision. Time metric, pretty straightforward. It just took how long it takes for the machine model to run. I ran it 10 times, and I took the average time as my end result. Accuracy is measure accuracy. This is going to measure the accuracy model by showing the correct number of predictions based off the ham and spam classification. Recall measures the total positives classification correctly from the positive sample. And lastly is precision. Precision measures the number of positives and not as negatives. In the concept of research, precision is attempting to class ham as ham and not spam as ham. So to make sure that no real emails go through as fake and no fake emails come through as real. So with accuracy scores, Bayes achieved an 83% accuracy score rating. Decision tree scored 89.8% accuracy, and Random Forest achieved an 88.8% over 10 runs, and I took an average over those scores. As you can see on the time measurements, Bayes took a whole 2.5 seconds to complete, which when I first read the timings, I thought it was an error, so I ran it again and again and again, but it was right. The decision tree took a bit longer with 12.5 seconds, and Random Forest took the longest with 14.5 seconds to run the algorithm. So, as we know, speed is key in some cases. So Bayes would obviously run one here. With a recall, Bayes achieved an 83.3% accuracy rating. Decision tree achieved a 98.8%, and Random Forest achieved an 88.7%. Precision scores, Bayes achieved an 83% score. Decision tree scored an 89.6% score, and Random Forest achieved an 87.9% score. So, which machine learning model is best for detecting my phishing emails? As you can tell, Bayes got the best time. However, time isn't everything. It was scored some of the lowest on accuracy, recall, and precision. Decision tree scored the best on accuracy, time, recall, and precision. So it scored the best on accuracy, recall, and precision, but scored okay on time. So, and Random Forest came last and everything. But we have to think of a large picture here. With timing is key, is important, but actually probably having better recall, precision, and accuracy is probably more important. So overall, in my research, decision tree was the best algorithm used to detect phishing emails. However, with my data, there's a few things what could have gone better. For example, there's more data was needed. Like I said earlier, this researchers aren't the best at sharing data, unfortunately, because these data sets need to be kept to date. So 5,000 emails wasn't the best. So maybe if I had 10,000, 20,000, 30,000 emails, I would have got better results. Also, with the real emails, they could have been a bit better because they're a bit old, and I couldn't find an up-to-date, legitimate email data set. But what is the future holding? Phishing is going to be a major issue, and there's no one-fix-all solution. As I said earlier, the current solutions can detect 99% of all phishing emails. But that still leaves based off our numbers from earlier, still leaves 31 million successful emails being sent to real accounts a day. Even if we incorporate spam filtering, phishing, the machine learning phishing based detection systems, still millions of emails coming through every day. So as working in a IT blue team sector, we should be focused on user training and user awareness to stop phishing attacks. Because as we all know, humans are the weakest link in any organization. It needs one person to click a link, and that can spread through a whole network. And thank you. This is the end of my talk. I'm not great again talking, so at the end, give me a shout afterwards and you can ask any questions you like. But thank you again for coming, and I hope you have a good rest of your day. So thank you.